The PCB Editor SKILL API includes a set of high-level user interface functions that allow you to programmatically solicit information from the user. There are simple confirmer windows, yes/no dialog boxes, a file browser, and a multiple-choice dialog, to name a few of the most commonly used UI functions. As an example, we'll update a function that we created in a previous training byte, which allowed the user to select an area of the design, and then report any connect lines in that area whose length was less than half of the width, and then also mark them with a DRC marker. We'll make our function more general by allowing the user to input the aspect ratio of the line to flag, rather than our current hard-coded value of 0.5. We'll also ask the user if they would like the wicked small segments flagged with DRC markers, or if the DRC markers should be left out. We'll use the Axle UI yes/no function to allow the user to decide if DRC markers should be included. Using this function is nearly trivial since it is a blocking function, meaning you cannot interact with the PCB editor, and the skill interpreter waits for the user to respond before continuing processing. Axle UI yes/no returns a Boolean value of either T or nil to indicate if the user selected the yes button or the no button. So we'll set a flag called add DRCs to keep the user's response. The first thing we'll do in our function is ask the user about the DRC markers using the Axle UI yes/no function. The first argument to the Axle UI yes/no function is the string to be displayed to the user in the yes/no dialog box. The second argument is optional, and is the title of the dialog that will be displayed. It will default to the title of the Allegro application, Allegro PCB Designer for example. If you do not supply the title now, a dialog will be displayed, and processing will wait for the user to respond. If the user selects yes, then add DRCs will be set to T, and if the user selects no, then add DRCs will be set to nil. Down in our function where the markers are added, we'll add a when construct, so that the Axle DB create external DRCs function is only run when add DRCs is set to T. Only slightly more complicated is having the user input a value for the aspect ratio we are looking for. We can use the Axle UI prompt function to ask the user for the aspect ratio. We'll use a variable called ratio and set its value to the return value of the Axle UI prompt function. The first argument to the Axle UI prompt function is the string to be displayed in the prompt window, and the second optional argument is the default value to be put into the dialog box, which we will set to 0.5. This argument must be a string, so we'll put it in quotes, and we'll also remember that the return value of Axle UI prompt is also a string. We need to perform arithmetic operations with this value, so we'll convert the user's response to a floating point number. The A to F function takes a string and converts it to a floating point number, or returns nil if the string does not denote a valid floating point number value. We'll also change our let function to a prog function, and exit the function when the ratio is nil, so we do not get errors if valid data is not entered. Finally, we'll update the part of the program that checks the ratio of length to width, and when the length to width ratio is less than the user's ratio, we'll report the segment and add the DRC, if requested. We can now save, load, and run our function, and as we see that when we run our function, the blocking yes/no dialog box is displayed, and the PCB editor is unusable until we respond, and we are then asked for the aspect ratio, with a default value of 0.5. If we just pick OK, and we select our area, the function completes. Notice that if we select no in the yes/no dialog, the segment is still reported, but no DRC error is added. Also notice that if we supply a ratio of 0.1, the segment is not reported. And finally, if we supply an invalid ratio, the function just prints a message and exits, which is much better than giving an error. In summary, the PCB Editor SKILL API includes a set of high-level user interface functions that allow you to programmatically solicit information from the user. There are simple confirmer windows, yes/no dialog boxes, a file browser, and a multiple choice dialog, To name a few of the most commonly used UI functions.